Today our focus in geometry is going to be on determining sine and cosine ratios and also how to use the sine and cosine functions that are on our calculator. Now kind of a couple things. First of all of the calculations that we're going to be doing are going to be based in degrees and not radians. So you're going to have to make sure that your calculator in its mode is turned on to degrees and not radians. Radians is just a different way to calculate your values, but in this section we're going to only focus on degrees, the beginning ideas about this. Now first of all, when I deal with the ideas of sine and cosine, first of all, sine is abbreviated SIN. Cosine is abbreviated COS. Those are the abbreviations we actually see in our calculators, as well as tangent, which is TAN. Now a lot of our calculation is based on being able to look at a certain ratio, like sine, cosine, or tangent, a certain trig ratio, and being able to figure out the sides that match up. So sine happens to be opposite over hypotenuse. Cosine happens to be adjacent over hypotenuse. And these are determined by actually looking at a certain kind of relationship as far as a focus angle. So I'm going to show you how to do that. Now first of all, use the triangle to write each ratio. So I have sine of t, cosine of t, sine of g, and cosine of g. Now I can tell there's two different angles that are mentioned here, which means they're really two different focus angles. So really what I'm going to do is I'm actually going to redraw the same triangle. Nothing's going to change about it except that I'm going to draw two of them. One of them that can be used for when the focus angle is t, and one of them that can be used when the focus angle is g. And I'm just going to start labeling things. First of all, on these triangles, because they're right triangles, there's no choice about the hypotenuse side. It's the longest side. So I can tell when they're all listed that this happens to be 17, or I know it can be the one that's right across from the 90-degree angle. So this side right here is the hypotenuse no matter what, and so is this one. Now, if I'm going to use this one as my focus angle for t, if I draw a line that comes out of t, it would hit this side 8 that's directly across from it. That side would be the opposite, which leaves 15 to be adjacent. Now by definition, adjacent means sharing a common side or a common point. So if I look at my focus angle, you can see that this side that's adjacent is actually what makes part of angle t. The hypotenuse would be the other side. So remember, adjacent is going to share a common point or common side with that angle. That's our focus angle, which is t. Now in this one, if our focus angle is g, that means this 15 right here is going to be opposite, and 8 is adjacent. Now, you are never going to have a focus angle that's going to be based on the 90-degree angle. It's always going to be the other two angles. And you must have a right triangle to do this. Okay, now, before we get going too far, just remember a ratio is a simplified fraction. So I'm actually going to make fractions for each of these, and my job is to reduce them if I can. If I can't, that's fine, but they have to be left as ratios. No mixed numbers, no decimals, no nothing, as a fraction. So first of all, if I do sine, sine is opposite over hypotenuse. So if this is the focus angle of t, opposite in this one would be 8, hypotenuse would be 17. Cosine is adjacent over hypotenuse in that same triangle. So adjacent would be 15, and hypotenuse would be 17. Okay, now for g, let the sine of g, so opposite over hypotenuse. And if I do cosine of g, adjacent over hypotenuse. Now, there are kind of a couple things that I'd like to point out as far as pattern about what you notice. Do you notice that they all have a 17 in the bottom? That's because the hypotenuse is the bottom of each fraction for these, and the hypotenuse happens to be the same number because it's the same triangle. So you all have 17. Also, do you notice these relationships here? The sine in one of these is equal to cosine in the other. Cosine in one is equal to the sine of the other. that relationship's an important thing to remember as we go on to kind of calculate some other things in the rest of the section. Okay, now if I'm looking at these, I also notice that I can't reduce them at all. 17 happens to be a prime number, and 17 does not go evenly into any of the rest of these. So that means that that's going to be our final piece. Now, I have included some links to YouTube videos that are in here. You could actually go through and highlight them and be able to use them. They all have some kind of focus on this piece that we often refer to as Sohcahtoa. Sohcahtoa is an abbreviation that we use in math to help us remember kind of sine, cosine, and tangent. So if you look at the abbreviation, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So when we're using these, this abbreviation can help us kind of figure out which one to use. In this section, we're only using sine and cosine, but remember, eventually they're going to be all mixed up. And our job is going to be able to figure out, okay, which of these ratios can I use? So any of these three may give you some good ideas about what to use. Okay, now let's actually put this to its test here. In looking at this triangle, I know that this sine where 10 is at is the hypotenuse no matter what. And x has to be my focus angle. Which means that, first of all, if you can't see this, this is 6.5. That side would be opposite. And adjacent has nothing. So if you're looking at this Sohcahtoa that we were talking about just a few minutes ago, and I were trying to figure out which of these three I could use, first of all, in looking at this, I can tell I have the hypotenuse, okay, and the adjacent side I can't use. The adjacent side I can't use because there's nothing on it. So that means that anything with adjacent is kind of cut off, which means tangent and cosine are out of the picture. But if I also look at this picture, I can see that I have an opposite side. So that lets me know in this one that I'm going to use sine is opposite over hypotenuse. So the sine of x degrees is going to equal opposite over hypotenuse. Now the big challenge for us is I really need to find the x, so I have to get this off. Have to get rid of the sine. Now normally we do what we call an inverse operation. If it's plus 5, we'd subtract 5 from both sides. If it were minus 10, I'd add 10 to both sides. So I've got to find the opposite of it, kind of this inverse. So to get x by itself, the inverse sign is what I'm going to do. So in my calculator, if I do the inverse sine, which on most calculators usually is some kind of a shift in the sine feature, something like that, so you have to make sure that you have that. Or at least find where it's at if it's not in that same spot. And then you could do that 6.5 divided by 10 in parentheses. So I end up with this one, 40.5416, and I keep going. That means on most of these, when you're talking about an angle, they're going to ask you to round to a whole number. So this is enough to make this round up. So I could say that this x is approximately 41 degrees. Okay, let's try one more here. In this one, they would like us to go through and use the triangle to find the sine of t, cosine of t, sine of g, and cosine of g, and write your answer in simplest form. First of all, because of the way this is written, I can tell that both t and g are focus angles. So that means, oops, I'm going to actually draw another triangle next to this and label it everything exactly the same. And I'm going to use one of these to be my focus angle when I'm looking at t. So sine of t and cosine of t. And sine of g and cosine of g. So in this kind of a problem, it's going to be important for me to kind of label my sides. Let's see. So first of all, hypotenuse is easy to see. In this one, if my focus angle is T, this side right here would be opposite, and this side would be adjacent. I'm actually going to label this triangle too because I think it's easier to do them all at once. If G is my focus angle, my not so straight line, here it goes to 16, that would be opposite, and 12 is adjacent. So I'm going to set up my fractions because remember they want ratios here. So sine of t would be opposite over hypotenuse. So opposite is 12, hypotenuse is 20. Now I can see by looking at these that they both have a factor of 4 that's in common. So if I was to reduce them, this would be 3 over 5. Cosine of t would be adjacent, which in this one is 16 over 20. And again, I can see factors of 4 inside of this, which will give me 4/5. Now these fractions are going to be the final ones. You're probably not even going to see these on there. They're assuming that you're going to reduce them if you can. Now to do this one, sine of g would be opposite, which is 16, over hypotenuse, which is 20. Now if I'm looking at this, gee, doesn't this look familiar? Which means this is going to end up reducing to 4/5. But remember, there is this relationship between these two when you're talking about different focus angles in the same triangle. That means if you're kind of starting to get the patterning here, these two should somehow match. So let's see. Cosine of g would be 12 over 20, which is going to reduce down to 3 over 5. Please make sure any of these that you are really going through and reducing as much as you possibly can.